To my lecture. Today we are going to discuss about the convolution and requirement for the Laplace transform. So first definition of the convolution. So the convolution of two functions f and g defined on closed interval 0 to infinity as f convolution g is equal 0 to t f of u g t minus u du. So now theorem for the convolutions Laplace transform. If Laplace of ft equal fs, Laplace of gt is equal gs, then Laplace of f convolution g is equal fs multiplied gs. So here we will take Laplace inverse to find the here we are going to use the convolution technique to find the Laplace inverse of this function. So here we denote it fs multiply gs equal to 1 over s plus 2, 1 over s minus 3. That means fs is equal 1 over s plus 2 and gs equal to 1 over s minus 3. You can change the other way. You can take it in other way. So then what is the ft? The Laplace transform, inverse Laplace transform of fs. This is equal 1 over s plus 2, which is e to the power minus 2t. And same way, Laplace for inverse for gs is equal gt, and this is equal e to the power 3t. So therefore, L inverse fs gs is the convolutions of ft gt, which is e to the power minus 2t, 3t, and the convolutions is defined as 0 to t f tau gt minus tau d tau. So this will give you 0 to t e to the power minus 2 tau, this one ft, and gt minus tau, so this is e to the power 3t minus tau. Then if we simplify, so e to the power 3t, because it is integration with respect to tau, e to the power 3t go out, so you have 0 to e to the power minus 5 tau d tau. Then we take the integration e to the power 3t e to the power minus 5 tau over minus 5 and substitute the limit. So you will get it this one minus e to the power 3t over 5 multiply e to the power minus 5t minus 1. Our next topic is solution of